I will directly start with the motivation for our smart logger series. If we look at requirements toward logging systems, we have general requirements coming from the ADAS and e-mobility, but also from the conventional development of vehicles. And people need to acquire data from many different sources. So they would like to capture data from cameras, but also from radar and LiDAR sensors. Of course, they want to have data coming from the vehicle network itself or from ECUs via various protocols. And they also want to measure additional external instrumentation. They also would like to include robust high-end analog measurement systems, as we know from CSM, for example, to save high voltage measurement. And of course, it is expected that all these different sources are correlated precisely in one recording, so that you have a chance to determine cause and effect in your measurement. There have been requirements towards a measurement system, and for economical reasons, as well as for safety and process reliability reasons, people ask to use logging systems. Economical because they want to acquire many miles of data. And of course, they don't want to send their engineers out to measure that data. They send out test drivers. And of course, they don't want to disrupt the attraction to road traffic by the measurement system. So it should be, or it should run in the background automatically. And also for process reliability, it is important to do the measurements always in the same manner. So if you later on want to create reports from that measurements, they should always look like the same. And that's why people use logging systems. I always call them measurement bots. But there are also other requirements coming more from the working process. If we look at the areas ADAS and e-mobility, we see a rapid increase of technical innovation. And on the other hand, we have at the same time shorter development cycles. As consequence, we see that the working processes between development and validation come closer together, and people often meet at the same prototype vehicles or test beds. That, of course, brings up the requirement that they would like to share assets. So they would like to share configurations or even the equipment. If we look at the performance requirements, we have new demanding tasks to fulfill. And what we can see in the e-mobility is that the sampling rates have been increased by factor 10 to 20 compared to conventional vehicle development. Also, the number of signals in total have been increased dramatically. As consequence, we have an ever expanding storage capacity requirements, and we have rising data rates. To handle these big amounts of data that are measured, people ask for more powerful online signal processing. So they would like to do high-speed online calculation on raw signals and just calculate some signals they are interested in. For example, in e-mobility, we have a lot of measurement points where we measure voltage and current, but we are interested in the power. So they ask for doing an online power calculation and only store the results. They also ask for the possibility to define more complex trigger conditions so that they can only record with high resolution in situation where a specific event happens. For example, they observe all the time the board net quality, and if some limits are hit, then they take a detailed measurement. In cases everything is okay, the system is just observing and waiting for the next event. So that's a way to reduce that big amount of data. And you only capture the essence at the end. If we look at the tool landscape that is used today, we see on one hand user-controlled measurement software like Canopy or vMeasure, where you have a full-featured software that gives you a lot of possibilities for the data acquisition. It can handle high data rates, etc., a lot of sources, and you have many possibilities to visualize your recording. On the other hand, we have autonomously acting logging systems. They have robust hardware, can handle the extended temperature ranges that are required at test trips. It's a unattended measurement control inside, and some of them also offer some remote configuration capabilities. It's two separated worlds, and there is not much of reuse today. Vector now merges the best of these two worlds in one solution by the smart loggers. So we created a solution that is able to serve both use cases with one system. Now let's have a look at the details of the concept. The basis of the smart logger is the software vMeasure or Canopy that is running on a computer with a user interface. You use it for configuration of the sensors, the ECUs, the interfaces. You use it to configure your measurement itself. You use it to trigger or define the trigger conditions. And you can also use it for visualization in interactive use cases. The difference now is that we move down the execution of the project to the smart logger. So the runtime engine is running on the smart logger, just the visualization is on the PC. The smart logger now takes over the job to synchronize all the different sources, has the connectivity to the sensors, the ECUs, the interfaces, and also the measurements are stored directly on the smart logger. So if you want to work interactive, you just use the PC with the UI connected to the smart logger, and you can run your task interactively as you would do it normally with Canopy or vMeasure or any other data acquisition tool. If you now would like to run the logger standalone, you just disconnect the computer from the smart logger, and the smart logger continues the recording and the measurement job as a bot. So it's standalone running on the logger. And if you would like, you can use a mobile UI to observe the smart logger and the status. You can see the filling level of the hard drives. You can also put some single signals on the screen that you are interested during the test trip. But it's a quite simple interface that just gives you the basic information. If you have now a situation where you would like to do some significant changes in the configuration, or you just want to have a look at the measurements that are currently running, you simply reconnect your PC to the smart logger and you jump in to the existing running logging process. So you can do visualization of measurements with all the features you have available in Canopy or vMeasure. You can also do ECU calibrations with Canopy and use all the features that you are used to. And the really smart thing is that you only have to unplug or plug in one cable. All the connected sensors, ECUs, etc., are connected to the smart logger as a central point. That makes it quite easy to switch between the two use cases. That's the basic concept of the smart logger. As I said at the beginning, we have a smart logger family. So let's have a look at the different variants we offer at our smart loggers. I already mentioned we have two flavors, vMeasure and Canopy. And depending on your use case, you use the tool that fits best. There are two basic questions to make the decision. The first question is, if you want to do ECU calibration, then it's clear you need to use Canopy. If you want to do only measurement tasks, then it's dependent on the, let's say, sources you would like to acquire. vMeasure comes with a lot of support of different sources, but some sources are only available with a Canopy. So if we look at the feature list, if you have the need to acquire ADAS sensors like radar, LiDAR, or camera raw data, then you need to use Canopy. Also, if you would like to do some message-based recording or raw data recording, then you choose Canopy. So these are the basic decision criteria. Now let's have a look at the, let's say, typical use case for vMeasure log. We see vMeasure log very often in e-mobility use cases where you would like to measure from ECUs and from vehicle buses. You also have quite high sampling frequencies required with your analog measurements. So you would like to measure signals up to 2 megahertz per signal. And you have total data rates of up to 2 gigabytes per second that have to be stored on the storage medium. You also would be interested in having online calculations, and vMeasure and also Canopy comes with a component called e-mobility analyzer function library that provides you online calculation for DC and AC voltage and current analysis, also power calculations, so you can calculate real, apparent, and reactive power. You can look at the efficiency, so you can calculate the power factor and the inverter efficiency or charger efficiency. You can do harmonics analyzations, etc., etc. So that's all available in a typical vMeasure setup, but could also be extended by Canopy. And you usually would be interested in the powerful trigger functionality of vMeasure and Canopy, where you observe calculated signals for a violation of some limits, and you will then take measurements. I have now a picture to show a typical setup. This is a testbed setup, which could also be built into a vehicle. I just choose this one because it's better to explain, because it's a little bit clearer in the structure. It's a symmetric system, we have two electromotors, two load machines on the test bed. We have the inverter and we have the battery simulation. So the system is now equipped with measurement equipment from CSM. So we have on DC side HVBM 1.2C in this case, and we have on AC side the HVBM 3.3C to measure on both sides currents and voltages. We also have additional measurement equipment installed to measure temperature in the inverter and also speed and torque at a motor. We now add to this system the vector part. So we have added these vector VX system to measure signals from inside of the inverter ECU. And all these measurements now go into the smart logger, and some online calculations will be done and recorded. So this is a typical setup for a combination out of CSM and vector products in a smart logger use case. Now I would like to have a look at a typical ADAS use case. This typically asks for the recording of data from cameras, radar and LiDAR sensors. So here we have multiple gigabytes to handle here because it's a lot of data that is coming in on these sensors. In addition, we would like to have the possibility to also measure the raw data from these sensors to have optimizations in the software code. We have the requirement that we have to integrate also customer-specific sensors with specific protocols, and the open interfaces of Canopy allows us to integrate customer-specific protocols here. We often have the requirement to record the Ethernet network, so automotive Ethernet. And a strength of the system is that we can record there also secured and encoded communication, and we can also provide the implementation of complex customer-specific Ethernet protocols. In the system, usually it's also required to do some calibration tasks directly through the smart logger without changing any wiring, and you can also change the code in the ECU in total. So you can reflash the ECU. So that's a typical use case for a ADAS test environment where you are using Canopy. The second possibility to select in the smart logger family is the hardware you are using. So we have three families at the moment. It's the VP6400 family, the VP7400 family, and the 7500 family. And if we would like to distinguish them, we can sort them into a performance and data rate scale. We have the mid-range logger for typical e-mobility use cases in standard setups, where we can do a lot of online calculations directly in the logger. We have enough storage capacity. In some more complex setups, the storage capacity and the writing speed is not enough, and we have to go to a higher performance logger class. Then we choose a 7400 and 7500 system, depending on the requirements. In the ADAS field, we usually use these loggers because we have a base load coming from the cameras and the LiDAR sensors that requires these bigger systems. If we have a quick look on the data sheet, we see the big differences here in this area. The storage capacity of the VP6400 series can be equipped with up to 4 terabytes storage capacity, and we get a writing speed up to 500 megabytes per second. With the VP7400, we can equip the system up to 16 terabytes, and we can write up to 1 gigabyte per second. With the VP7500, we can equip the system with 32 terabytes and can write up to 2 gigabytes per second. So that's a lot. And we are sure that we have a system that fits to your needs. Okay, I'm at the end and I'm going to give you a summary. What is smart at our smart logos? First of all, we have a comfortable and fast handling, and we can switch between the standalone logging use case and the interactive working use case with the same hardware, with the same configuration. You don't have to change any cabling in your car when you jump between the use cases. So you have really very low setup times to switch between the working ways of working. We offer you a use case related interface. So if you would like to work interactively with the system, you can use the full featured canopy or vMeasure user interface. If you're in the car, you can use a simple web-based interface running on a tablet PC to just give you an overview on what's going on in the smart logger. We offer you possibilities to more easily solve your complex tasks. That means we offer you GUIs to configure, for example, your power measurement, your ripple analysis, etc. So it's a user-guided configuration dialog where you can just configure your measurement easily. And we also provide you a simple interface to define your trigger conditions so that you can significantly reduce the amount of data you are acquiring. We can measure nearly everything. So we also support complex protocols such like some IP on automotive Ethernet, or we can integrate customer-specific proprietary protocols. This capability was always there with Canopy or vMeasure, and now we have it also available on the data logger. So that means even if you have something running on your Canopy PC, you can take it over to your smart logger setup. We have a tailored solution in total. So you have these smart loggers you can select out of a big range of hardware, but you can also extend the smart logger. So you can attach any vector interface to the smart logger if the number of interfaces at the smart logger itself is not enough for your use case. So for example, you can add additional Ethernet selections. We have adaptability, I said it already, so we can quickly customize the system and add your protocols into the system. And we have a big scalability in terms of smart logger hardware. You have 3 platforms available where you can choose out of, and there are several variations in terms of number of interfaces and storage capacity. So this is a new concept for data logging integrating the interactive and the autonomous data acquisition tasks. And we hope that this is interesting for you. And if you have any questions, feel free to come back to us and discuss your use case. Thank you.